I think I'm going to kick off then. So, housekeeping from my side for this specific talk of mine. I encourage everyone to ask questions, and you can do that by any means possible, be that unmuting yourself and interrupting me throughout the deck. That's perfect. I most likely will be able to make the 45-minute mark without a problem. Probably will finish a couple of minutes early, but yeah, there won't be there's no big deal if you interrupt me throughout the presentation. There is, however, will be time at the end for Q&A as well, if need be. So first of all, full disclosure, my name is Andreas Bergstedt. I work for Microsoft. I am part of the Azure business, and it will be interesting to know that obviously the analytics track is part of my remit. I work for a team called Global Black Belts. We are pre-sales solutions architects, effectively, that help with escalations or technical and conceptual or architectural escalations, and act as a buffer between the customer and program group and engineering. Right. So that is the disclosure piece. In terms of my history, my professional history, I've pretty much been a jack of all when it comes to the IT scene. I've done everything from being a counter PC technician, operator, to network administrator, sysop, that sort of thing, to being BI architect, and sort of looking after the sort of data architecture piece. I guess my most humblest point, since I work for the Azure business within Microsoft, for me in terms of my career, was I resisted the cloud and cloud concepts for the longest period of time, and that leads me into this. I'm very, very passionate about data engineering and ETLs and moving and processing data. It was always one of my fortes as a BI architect. But I resisted the cloud concepts and the modern concepts for about 4 years too long. And that is my sort of full disclosure. The cloud wasn't something that came easy to me. So with that in mind, today's call is called From Metadata to Lakehouse. This is a sort of level 1 to 200 session. It is we're going to go through some concepts. I'm not going to show any actual demos in this slide. In the slides, I will, however, make code repositories available for these concepts with actual artifacts that you can lab and play on your own. Right. So with that in mind, let's get started. So I have broken up this talk into 4 sections or 5 sections, including the takeaways. The first one is a bit of history lesson called The Evolution of ETL. And this is just setting the scene of where we've been, how data concepts have evolved over time, or data movement concepts have evolved over time into the more modern data engineering concepts. And then we segue into why Lakehouse is an appropriate sort of target architecture, if you want to call it that, for how to store and process your data, and what the patterns are, and how they benefit us, and also looking into the metadata-driven engineering concept. So, what is important to think about, how these work in practice, and what are the benefits of those. And then I have a bit of a governance track as well, that I feel goes hand in hand with data engineering and metadata driven concepts, because we need to be able to work at scale. So whilst metadata driven concepts and data engineering practices gives us a scalable framework to operate within, we can't lose control of that, right? So we need to drive that operationally at scale. And then we'll finish off with 3 key takeaways and open Q&A. Cool. So let's get going. So when we think about the evolution of ETL, right? We got to remember that since the birth of the database management systems in the in the 60s, there's always been a need to move and load data from one system to the next. And in the beginning, this was driven by batch and sort of shell scripts that were either triggered by a human. We would run some commands that would execute a set of data movement operations, or we would have scheduled tasks and cron jobs, right? Then in the 90s, we started getting sort of the explosion of the data warehousing sector, right? Data warehousing became a big thing. And we started getting, towards the end of the 90s, we started getting the sort of the influx of more modern sort of data movement tools, data orchestration. So we have here, picture of data transformation services that many people didn't like. And we got Informatica. We had SSIS start bringing a bit more splitting between control and data flows. Oracle ODI. These are systems or solutions that sort of driving the ETL frameworks at larger and larger scale, right? And then something strange happened. We got the sort of the influx or the advent of cloud databases and polyglot storage in the 2000s. And with this, we've got the popularization of the cloud sort of data warehousing concepts between 2013 and 2016. And we started seeing the processing shift going from where we would have a purely sort of GUID-based drag and drop kind of interface where we would build things within it, to the concept of that got popularized by sort of DevOps patterns. So the whole infrastructure as a code and all that, where you would just load, you'd have configurations, you'll push them out, and that would sort of drive at sort of a cloud scale. And then obviously from a Microsoft perspective and an Azure perspective, we ended up with Azure Data Factory version 2 and Synapse pipelines. And these were modern concepts and still are modern concepts that are truly tested, right? So good ways of handling code orchestrations. There are a few others, such as Airflows and those that are also very prominent in the industry, but they're out of scope for this talk. So at the same time as we started getting into this mainstream cloud adoption, we also saw a strange phenomenon happen. We started getting a bit of influence from the data sciencey world. So the Apache Spark project started getting popularity, and it was sort of held or accelerated by Databricks as more of a commercial venture of building these mainstream concepts. And Databricks introduced obviously Delta Lake. It's their proprietary, or was their proprietary technology, so the Delta table concept. And this sort of started taking the shift of the Lakehouse. Databricks obviously coined the Lakehouse term. It was their original idea. But then we got to look into why Lakehouse. What is the purpose of Lakehouse, and why is it such a fundamental corner piece of data engineering today? Well, for the longest period of time, we've been trying to build solid architectures in sort of cloud and hybrid cloud architectures, right? And this has been always a bit of a complex operation. There's a lot of moving parts to deal with. There's a lot of things to take into consideration, and your concepts may look very, very simple. However, there are a lot of things to think about, right? So if we then start looking at, okay, well, what are these pieces, and you start looking at what's available in the cloud today, then it starts getting really scary. And anyone that looks at a picture like this and thinks, well, which component is appropriate for this operation? We start narrowing down and seeing the landscape and how can they fit together and all of that. If we try to fold back and sort of understand what Delta or Lakehouse is important, is that we're trying to simplify the storage components. We're trying to make it easier for you to operate, within a sort of a simplified set of rules. And let's just go through those. So if we look at data lake architectures, right, where Lakehouse stems from. So data lake was great, but it added a whole bunch of complexity. So data lake was great because you had common storage, and you had the ability to rapidly process, and you could sort of segment your domain areas, your interest areas, into different slices or segments. But it was complex. There's little governance or hard to govern a large data lake estate. There's very little frameworks, and data lakes were obviously very segregated between the data engineers that had their very structured way of doing things and data scientists that, hey, we're just going to explore and start building stuff because that's cool and funky. Now, when Microsoft tried to simplify this, we first started introducing the modern data warehouse approach, where we thought, hey, let's just use our cloud scale data warehouse as a serving layer, and then we slot analysis services on top of that, and we serve it out. And then for the data engineering and data science piece, we're just going to have a clear split where, we load all our data in storage, and then we have engineering pipelines going into data warehouse, and then the data scientists can build models, and we can then link them in through prediction functions and link them in through our data warehouse processing, right? And yeah, it was an okay idea. At the time it was valid, but as Synapse Analytics started maturing, or as we moved from the monolithic Azure SQL Data Warehouse mode to the Synapse Analytics mode, where we try to unify Canvas and put both data scientists and data engineers and also other data citizens inside of the single canvas. It kind of, we unified the process, or at least the space where people could work, but the processes were largely split, right? Now, whilst Synapse Analytics, facilitates the Lakehouse architecture, and it does it quite well, we got to sort of understand that, with the advent of what's being announced recently with Microsoft Fabric, there was some weaknesses that we had in Synapse. It wasn't fit for every purpose, but it is getting better. So if we then start looking at the medallion architecture, that is sort of the trademark of, or the hallmark, should I say, of the Lakehouse architecture. So the medallion architecture aims to, or is taking the pedigrees of the data lake concepts, and it tries to simplify them. And this is the whole point of the Lakehouse architecture, is trying to fold and simplify everything into 3 rationalized layers, right? So you have your bronze layer, which is reminiscent of raw, where you do zero transformations. You just land data as is. If it's relational data, just store it as Parquet. You historize it by data partitions, and off you go. The silver layer is traditionally a one-to-one with bronze. However, here you've standardized on the Delta format, or the Delta table format. You're doing things like proper historization, and you have the ability to merge and cleanse data. Very light transactions in here in terms of data cleansing and data quality management. And then you have your gold layer, which is your rationalized business models, right? So here's your data marts, your facts, your dimensions, and all of that. And in this environment, you serve up to the customers, right, or to your user base. Typically, if you're looking at more modern domain architectures, your gold layer is always where you define your data products. Cool. So if we try to rationalize this out into a basic architecture, so this is how I see it and how most of my colleagues see it in the Azure business. And this has currently got Synapse Analytics here. This could be anything from Databricks, your own Spark VM, whatever it may be, right? But for us within the Azure team, this is how we see it. So simple ingestion into bronze. We run Spark workloads to process our bronze data into silver layer. Another set of Spark processes to process data into our gold layer, and then served out with whatever compute, either a serverless compute wrapper on top, or if you load into data warehouse, endpoint at that time, and you serve it out into your enterprise reporting. Right. Before I move to the next section, are there any questions in the chat? Bear in mind, I can't see the chat. Oh, here we go. Go back. So let's see. Yes, you can get the presentation afterwards. What is the use case for using data from silver layer? Right. So consuming data out of silver, the use case for that would be to, from a data science perspective, or if you want to explore models and that, I would consume that out of silver. If you're looking for trusted data that has been standardized, in other words, you're not consuming out of bronze because you're not trying to discover new use cases, you just want raw or non-aggregated data, then I would use silver layer for that. And the purpose of obviously building out of silver would be so you can create a data product in the gold layer, be that a data model, a tabulated wide analytical data model, or a new data mart environment, right? So that would be the use case for silver. I hope that answered your question. Oh, here's another one. Right. What is the right? So here's some migration questions. So what is the guidance for companies that are deeply invested into the SQL Server and SSIS architecture? I'll tell you what, Bernard, I'm going to take that one at the end because it's a bigger topic. Right. And the next one from Rishak, I'm going to answer in the next couple of slides. So let's carry on with the deck, and we'll get to them in the end. Cool. Right. So if we're now looking at the metadata-driven engineering concepts, or the data engineering concept, so there are tons of frameworks available out there, and for free. There's a lot of community contribution. I have a few abysmal ones lying around on more than one GitHub environment for me. But if you do a quick search on GitHub, yeah, here's one for metadata ETL. You will get a whole bunch of data management frameworks coming up, and these are, yeah, most of them are good. Most of them are maintained and valid. And there's tons of IP out there that you can consume that will work with mostly any use case, right? So there's GitHub is a great resource. So if we look at from a data engineering perspective, let's consider this scenario or this architecture. We have batch integration using ADF into our bronze layer, 0 transactions. We might have a real-time data set as well, where we use Stream Analytics to rationalize this as the data comes in. In this case, we would bypass that straight into Silver because technically our raw form would be already managed. Then we run a Synapse process to lift our bronze into Silver. Now the Synapse Spark process to lift into gold or push it into a dedicated pool, right? And then we serve that out. Well, in this architecture, we say we run a virtualized store with serverless endpoint to carry on serving. And I'm assuming that is a valid use case, right? So if we look at this example and we look at the, well, actually, let me step back here first. If we look at this architecture, we can see some clear boundaries. And I want to stress this. When we moved from ETL to ELT concepts, or well, from ETL, from on-prem and your hosted data centers or your private cloud infrastructure, to moving to the cloud, boundaries became paramount, right? And this is where the shift went from ETL to ELT. So what I want to make clear is that from a data engineering perspective, it's always important to define boundaries, because your boundaries become that, how you can fold processes into the smallest, most narrow component and then just duplicate or replicate that over and over again, right? And reuse. So the first boundary is your ingestion boundary, right? So you got your first weak point is how you get data from a source system into your bronze layer, and then you get another clear processing layer boundary, right? So between bronze and silver, and then the final clear one between your silver and gold, be that polyglot store with delta tables, or be it a dedicated pool or another SQL endpoint or whatever it may be, right? So if we look at these from a component perspective, so imagine we're going to walk through how we process data from bronze to silver, right? So imagine you have a generic notebook. In this case, it takes Parquet data and loads it into silver, or this. It basically is just driven by input parameters. So we get a set of batches, right? We get told what our input format or bronze format is, where it's lying, a bit of config stuff around logging, etc., and we process it. So a generic notebook to handle one specific layer of the transaction, right? Now, if we take that and we put it into Synapse Analytics, we can see here that we have some clear boundaries. So the first boundaries is our child pipelines, and this is where we have our control, our lowest level of detail, right? So this one is this Parquet to silver pipeline, which all it's doing is executing that same notebook, right? And then we have our control pipelines. Now, these are pipelines that will go and collect configurations that we have stored in our configuration data stores, right? So here we're getting batches for processing. So we can see here a list of tables attribute is we can see this JSON array of things. So we got a table name, partition key, and some UUID. And this is, in this case, this is just a GUID from a transaction table or log table. And there's other things we pass in, obviously, to sort of being able to execute these batches in a notebook, in a Spark jobs. Right. And then finally, we have orchestration pipelines. So here's like the three components, child pipeline, control pipeline, and then the orchestration pipeline. And this is some rhythm-based control logic. So in this case, I have a daily and an hourly batch window where I load. So my daily batches literally just, well, we do some metadata configuration or updates or validations. So store procedure gets executed. We then go and process our raw layer. So we take our oh, sorry, this was my daily batch, not my hourly batch. But in my daily batch, I run the whole process. So set my metadata, process my raw layer to silver, and then I grab my silver data and processes those into the gold layer. I can also control then on an hourly basis. So in this case, I'd have an hourly batch that takes where I load from source, take my deltas from or my incrementals from my source systems and push them into the raw layer and into silver. Right. So if I run that on an hourly basis, and then I use daily big process batches. Right. So this is typical example of how data engineering can work. Now, obviously, since we had Kim on and she talked about Fabric this morning, this is how we see this in the context of Fabric. So all we're doing is we're taking all the workloads and we're wrapping them into the Fabric umbrella. We can still have control logic using Data Factory for external orchestration, but essentially Fabric's Data Factory transformations will handle the ingestion. We'll have our Spark jobs to push data forward. We'll have ADX capability to process real-time data and then push that into either a silver or into a gold layer, and then we can real-time with Lake Direct run Power BI visualizations on top of that data, or run experimentation using the Lakehouse SQL endpoints. Cool. Right. The next segment is called Driving at Scale. Now, this is very much aligned to data governance, and this is I just want to quickly talk about some processes and how we can adapt to more modern ways of work. So operational frameworks like data mesh and those, right? So with data mesh, so if we think back about 2 years ago, and we looked at most of the data mesh presentations, right? Data mesh was presented into three versions. You had a governed mesh, you had a harmonized mesh, and you had a fully federated mesh, right? And those were the sort of control boundaries. But over time, this has become increasingly complex, right? So now we're starting to see things where instead of having individual ownership at a domain level, we're also starting to see now things like we want domains clustered together. If you look at the value chain aligned mesh, where relationships and contracts between the different teams and domains have become increasingly complex and obscured. So data mesh concepts have influenced the data engineering community quite a lot, right? Now, from the point I want to make here is that in order for us to be able to manage and maintain our data state and our lake houses, we also need to take data governance into account, right? And a simple way of doing that is just to start defining our lake houses in Microsoft Purview, right? You can use any governance tool or process you're familiar with. but I would obviously recommend Microsoft Purview. So you can leverage the concept of collections in Purview to, as we see here, we literally mimic our Lakehouse. So we see our domains or our business units, right? And then we've created our Lakehouse zones underneath those. And this enables us to establish, data and control plane access easily. We can, easily determine data ownership, right? Because as much as central functions like IT traditionally likes to think that they own the data that gets processed, or a data services division within the business feels that they own the data that processed, we're all wrong in that statement, right? Data is always owned by the actual domain or the business unit. It's never owned by a central function like IT, right? It also, doing it this way, helps us establish common process patterns, and that is paramount from a data engineering perspective, because you want to create these boundaries. So if you now need to start, having to easily define, or you need to define scope for like how we do policies and workflows with our data and how we share it, if we haven't described data this way, or started like shaping our data ownership, the common processes around how we structure our data catalog and our inventory, according to a Lakehouse style architecture, then it starts to get really hard to start automating things. And then also this enables, if we're doing all of this, we're also enabling self-service data democratization. So this is to that silver use case. If you're an analyst and you have access to metadata around the silver, one of the silver zones for, I don't know, manufacturing or logistics, right? And you need to start expanding a use case, you're able to search quick and easy based on that collection. You can limit to data that's present in the silver layer, and Purview will then give you the correct answers back in terms of what's in your shopping list, and then how can you pull that data back. And also, hey, it promotes data literacy for the rest of the business, and it's always good. The other thing also is that as data engineers and data practitioners, we should always encourage and practice good stewardship. So with this, I mean, we should follow things like the definition of done. When we get a request in to build something, we should follow through to what is my definition of done, and part of definition of done should always be documentation or documenting ownership, or using, contextualizing what you build into a business asset, right? So in this case, I have part of the meta model landscape in Purview, and I've pushed it here. And the reason I put it here is because you don't have to manually document this stuff. You can publish, if you have, because we built up clear boundaries, you could always put the sort of the publishing of a business asset, be that an API, a REST endpoint, or whatever it may be that you need to describe as a business asset. You can always do this through API integration and in your final stages of your development. So you always push out fresh metadata about what you built as a data product, that then including the ownership and who the domain expert is, and also the source data about it. And that goes, if we use native capabilities, that just drives and enables visibility, and that's super important, because if we pushed our work into the business artifacts or the business assets within Purview, that means that a business analyst can come and do an impact analysis and then determine already ownership who needs to be notified, what are the downstream effects on technical artifacts as well as business artifacts, right? So it's important. Let's try to use native capabilities to enable this visibility. But with that, I've got my key takeaways. So from the session, the first thing I want to say is just metadata-driven data engineering provides clear data boundaries at scale. And that is true. Data engineering narrows down to the smallest artifact with the most common ground, and then we iterate over those, right? So clear boundaries and then generate scale at that level. The second takeaway is that Lakehouse patterns are scalable, long-term supportable concepts, and this is 100% clear. There is not a hyperscaler on this planet, be it Microsoft Azure, be it AWS or GCP, or even if you look at the cloud data warehouse platforms like Snowflake that aren't at some part of this discussion at the Lakehouse concept, right, or at that table. And we can see from obviously community, the Lakehouse pattern has been driven predominantly by community interest from the data engineering community. So there is massive push for this, and it's the concept itself of separating or getting the sort of the compute storage layers fully segregated. They are, that as a concept is a winner in the long term for sure. And as we see products mature, like Microsoft Fabrics now in public preview, we're adopting this because we see it long term, right? And then the final takeaway is that data engineering goes hand in hand with data governance. And there's no question about that, because as your platforms evolve and scale, as business grows, so you need to always build the data governance on top of your data engineering concepts, because without it, you're just going to lose control. Cool. And with that is the last slide I have. Let's have a look at some of the questions. So let's start with the first one from Bernard around companies that are deeply invested into SQL Server and SSIS architecture. So there are a couple of ways of moving to the cloud. So obviously, Data Factory has its SSIS runtime capability. So you got this lift and shift motion that's been around for a very long time. Obviously, all this does is enables you to run the same monolithic approach in the cloud, right? There are a couple of ISV vendors out there that do code conversion. Some of them are really affordable, and I think there are a couple of open source projects as well around that does SSIS conversion to ADF patterns and or Spark jobs, right? So there are a couple of options for you there. So if you're deeply invested in SQL Server on-prem, well, SQL Server, it depends on where you are. But if you build SQL Server data warehouses, obviously Microsoft Fabric is a great target architecture because the data warehouse endpoints are transactional, so you can run workloads there. But also Synapse Analytics has got some really good value for money and appropriate concepts. And obviously you can run SQL Server, so you can do without code translation. You can run SQL Server natively in Azure as well. So concept like Arc-enabled SQL Server 2022. You can just create a failover point from your on-prem into the cloud, and all is good. Cool. Next question. Right. If you want to homogenize the data into domain models, will it be silver layer? Well, this is this is a bit of a religious discussion or religious concept. So it all depends, right? If you've got, so let's say that uh, mm, let's say that the principles are always around models or products. Uh, um, um, a domain should always produce a data product, and then you can set a principle that data products should always be surfaced in gold. So then, no, it won't be silver layer. You'd have your source data in your silver layer, but your model data will always be surfaced then in your gold layer because that is ready for consumption and ready, it should be business grade sort of data that ready for consumption. Synapse dedicated to Fabric migration. So we have this one's tricky. There are let's just say that the Fabric team is heavily invested in supporting this. And the idea is to make it more of a tick box exercise than an actual migration project. And we're working through this. Portions of the Synapse Analytics migration might go through a code translation style exercise, and some of it might be just a tick box to say, hey, I had dedicated pools, or if we do a more of a religious skit version of it, it's like, no, you were meat and now you're chicken kind of thing, right? So we're we're looking at trying to automate these things as much as possible by and make it as smooth as possible for end users. Cool. Yeah, that's a GitHub library. It is old. You should use the new library. I will surface all artifacts, all code artifacts in there. With that, thank you very much for your time.